This is Lesson 4-4, Part 1, Writing Linear Equations.
Okay, number one, the first thing we need to do is find the slope between the 2 points. So my change in y is a -5, and my change in x is a +15. So I have that my slope is -5 over 15, which reduces to -1/3. Okay, now we're going to go ahead and pick a point. Doesn't matter which one you pick. I'm going to go ahead and pick the second one. This will be my x1 and my y1. So when I plug this into my equation, I have y minus 3 equals -1/3, parenthesis, x minus 12. We're going to distribute the -1/3 through, so I get y minus 3 equals -1/3 x plus 4. Add 3 to both sides, and our answer is y equals -1/3 x plus 7. If you'd use the other point, you still should have the same answer. Problem number 2, we want to find our change in y over our change in x. So we're finding our slope. So from -6 to -6, that is 0. From 15 to 1, that is a -14. So my slope is 0 divided by -14, which is just 0. Okay, I'm going to pick a point. I'll go ahead and just pick the first one here. So x1, y1. When I plug this in, I get y plus 6 equals 0 times x minus 15. Now this whole thing is just 0, so I have y plus 6 equals 0. Subtract 6 from both sides, y equals -6. Now hopefully some of you saw a faster way of doing this problem. When I look at my 2 points, I can see that y both times is -6, so I know that my equation is going to be y equals -6.
Okay, number 3, write the equation of the line that goes through the 2 points. So the first thing we're going to do is figure out what the slope is. So y minus our y, so -7 minus -1, and then x minus x, 3 minus 3. So what I've got is I've got -6 divided by 0, and since that is an undefined slope, that means that I'm going to have a vertical line. And so that's going to be an equation that goes through the x-axis. So if you think about your x and y axis, okay, so there's x-y axis. It's going to go through the x-axis, and it's going to go through the x-axis at +3, and so my equation is going to be x equals 3. Another way you can think about the same thing is if you'll notice that both of the x coordinates are 3. And so if both of the x coordinates are 3, then that means no matter what y is, x has to equal 3. So that's another way that you can think of to write the equation.
Number 4, our change in y is 10. Our change in x is 5. So m equals 10 divided by 5, which is 2. I'm going to go ahead and pick a point. I'm going to use my first one here because there's a 0 in there, and I always like to use a point if there's 0. So I'll use 4, 0 for my point. So to plug that in, I have y minus 0 equals 2, parenthesis, x minus 4. We're going to distribute that 2 through. Y minus 0 is just y equals 2x subtract 8. So there's our answer for number 4. For number 5, our change in y is 8.7. Our change in x is 5.8. So I get m equals 8.7 divided by 5.8, which is 1.5. Okay, I'm going to pick a point. I'm going to go ahead and just pick the second point here, x1, y1. So when I plug this in, I have y minus 3 equals 1.5, parenthesis, x minus 8.1. Distribute that 1.5 through, we get y subtract 3 equals 1.5x minus 12.15. Then we add 3 to both sides. So our answer is y equals 1.5x minus 9.15. So that's the equation for number 5. For number 6, we want to find our change in y, which is a positive 3, and our change in x, which is a negative 6. So m equals 3 divided by negative 6, which reduces to negative 1/2. I'm going to pick a point. I'm going to go ahead and pick the second point here. I've got my x1, y1. And once again, it doesn't matter which point you pick, you'll get the same answer. So I have y minus, actually it's y minus a negative 2, so that becomes y plus 2 equals negative 1/2 parenthesis x subtract 7. And now I want to distribute that negative 1/2 through, so y plus 2 equals negative 1/2 x plus 3.5. We're going to subtract 2 from both sides, so my answer is y equals negative 1/2 x plus 1.5. Okay, for number 7, we want to find the reciprocal of 8. Now remember that this is the same as 8 over 1. The reciprocal is where you take the numerator and the denominator and they switch places. So the reciprocal of 8 is going to be 1/8. For number 8, we have negative 5/11. So to find the reciprocal, I just switch the numerator and denominator. So my reciprocal is negative 11/5. For number 9, I have 1/7. Once again, my numerator and denominator are going to switch places to find the reciprocal, which gives me 7 over 1, which is the same thing as just 7. And our last one, number 10, is negative 10. I can go ahead and put that over 1 and show that those two are going to switch places, the numerator and denominator, and that is negative 1/10. Okay, that's our warm-up. Now we're going to go ahead and talk about the lesson. We're talking today about parallel and perpendicular lines. Okay, our first one here is parallel. And this symbol right there, those two lines, they're look like two parallel lines, that is the symbol of math for parallel. So I can actually use that symbol instead of writing out the words parallel. Okay, so parallel describes the relationship between two lines which are on the same plane and never meet or never touch. The two lines are always the same distance apart. That's called equidistant. Then parallel lines have the same slope but different y-intercepts. If they have the same slope and the same y-intercept, they would be the same line. So parallel lines have to have the same slope but different y-intercepts. Okay, our next one is perpendicular. This is the symbol for perpendicular. It describes the relationship between two lines which meet at a right angle. Right angle is the same thing as a 90-degree angle. So when those two lines intersect, they create a 90-degree angle. A line is said to be perpendicular to another line if the two lines intersect at a right angle. If two lines are perpendicular, then their slopes are opposite reciprocals. This is an important part right there. Their slopes are opposite reciprocals. And our last one, if the slope of one line is 0 and the slope of another line is undefined, the two lines are perpendicular. Then we have reciprocal down here. It's called the multiplicative inverse. When you take the inverse of a number, the result is the reciprocal. And a number multiplied by its reciprocal equals 1. So if I have 2/3 and I multiply that by its reciprocal, 3/2, I get 6 over 6, which equals 1. So any number multiplied by its reciprocal will always equal 1. Okay, then we have the definition of slope there. We have our delta y over delta x. Remember that delta means change in. So what that really means when I have delta y over delta x, This is the change in y divided by the change in x. And we're going to be doing lots of slope today. Okay, we're going to find the slope of a line parallel to the graph of each equation. So first of all, I need to identify what is the slope of this line. Remember, this is in the y equals mx plus b form. And m is our slope, so you can see right here that 5 is the slope of this line. The slope of the line that's going to be parallel to this line has to have the same slope. So if the slope of this line is 5, the slope of a line parallel to it also has to have a slope of 5. So your answer number 1 is that the slope is going to equal 5. Okay, for number 2, we have y equals negative 3/7 x plus 2. Once again, I want to find the slope of this line, which is negative 3/7. The slope of the line parallel to this has to be the same slope, so it's going to be negative 3/7. So the slope of the line that is parallel to this line has to have a slope of negative 3/7. It has to have the exact same slope.
Okay, in this one we are looking for what slope does a line that is parallel to x equals negative 3. So what is that slope? So if we think about this, it only has an x, which means that this line is going to go through the x-axis at negative 3. And so anything parallel to that is also going to go through the x-axis. And so anything parallel will also be going through the x-axis, which means that it's also going to have the same slope. And because it's a vertical line, that slope is going to be undefined. And so that is the answer. Anything parallel will have a slope that is undefined. Okay, we're going to stop for just a second, and I want you to find a place on your notes where you have some blank space. We're going to give you a little analogy, something to help you remember about vertical lines and horizontal lines and undefined slope, zero slope, just a way to help you remember. So find somewhere where you've got a little bit of blank space where you can draw a few pictures, and we're going to give you an analogy to help you with that.
Okay, so I have a horizontal line right here. This is a horizontal line. And there's a snowboarder that's hanging out on this slope. Okay, and let me draw him in there. And he's just standing there, chilling. All right, on this horizontal line. If he's just standing there, how fast is he going? Is he moving at all if it's a horizontal line? Well, no. So his speed would be 0 miles per hour. So if it's a horizontal line, a snowboarder is going 0 miles per hour. That helps us remember that the slope of a horizontal line is 0. Also, we need to remember that to write the equation of a horizontal line, it's always going to be y equals the number where it crosses the y-axis. So, remember, if we have a horizontal line, the slope is always 0, and to write the equation, it's always y equals the number where it crosses the y-axis. Okay, let's look at a vertical line now. So once again, I have a vertical line here. And we're not just going to say this is some vertical line. This is a nice big drop here. Let's say it's 500 feet. Okay, and once again, we got a snowboarder. This is a different snowboarder. So he's got a different color board. Okay, and he's hanging out in green clothes. All right, and he's about to go off this cliff here. It's a vertical drop of 500 feet. Now, what is the slope of a vertical line? Well, we know it is undefined. Okay, that's our slope. Our slope is undefined. Now the way to remember this is that if you snowboard off an undefined slope, you are going to D-I-E, die. So if it's a vertical line and you try and snowboard off that, you're going to die because it's an undefined slope. To write the equation of this line, it's always x equals whatever number it's crossing on the x-axis. All right, let's go ahead and get back to the lesson now. Okay, so now we're going to go over 4, 5, and 6. This time we're going to find the slope of the line perpendicular to the graph of each equation. So number 4, we have y equals 3x. So first of all, I need to identify the slope of this line right here. What's the slope of this line? Well, we know it's 3. So our m equals 3 here. So what does the slope of a line perpendicular to this have to be? Well, first of all, it has to be the opposite reciprocal. So if this one is a positive number, then the one perpendicular has to be a negative number. This is 3 over 1. The reciprocal of 3 over 1 is 1 over 3. So the slope of the line that's perpendicular to this line is negative 1/3. And I can see that I have opposite signs, and they are reciprocals of each other. Okay, number 5. This one is y equals negative 5 halves x subtract 6. I first want to identify what is the slope of this line. It's negative 5 halves. So what is the slope of the line that is perpendicular to this? Well, if this is positive, this other one here has to be negative. And then this is 5 over 2. The one perpendicular has to be 2 over 5. So they are opposite reciprocals of each other. Okay, and then number 6. If I have y equals negative 4, what is the slope of y equals negative 4? Well, if we go back to our little snowboard analogy, I can see that if it's y equals a number, my slope is 0. So I know my slope here is 0. So what is the opposite reciprocal of that? Well, if we look down here under perpendicular, it tells us that if one slope is 0, then the other one has to be undefined for the two lines to be perpendicular.
So if the slope for this line, y equals negative 4, is 0, then I know that the slope for any line that is perpendicular will have to be undefined. Because y equals negative 4 means it's a horizontal line going through the y-axis, and so anything perpendicular to that would have to be a vertical line going through the x-axis, which has an undefined slope.
Okay, for 7 through 14, our directions say we're going to find the slope of each line, and then we're going to determine if the lines are parallel, perpendicular, or neither. So I first of all want to find the slope of our first 2 points. So from 8 to 11 is 3, and from negative 3 to 5 is 8. So that means that my slope for this one is 3/8. Then my other point from negative 1 to 2 is 3. And from 6 to 14, that's also 8. So the slope of this line is 3/8 as well. Since these two lines have the same slope, we know that they are parallel. Now, I don't want to write out the word parallel or perpendicular every time. So fortunately for us in math, we have this great symbol we can write instead. So I'm going to go ahead and put the parallel symbol and then put a box around that to show that's my answer. Because they have the same slope, they are parallel. Okay, you go ahead and try number 8 to find the slope of each set of points. I'll give you about 30 seconds to do that. on the first set here, we can see that we have 2 over negative 6. So our slope, that reduces to negative 1/3. On the right-hand side, we have negative 3 over 1, so that slope is just negative 3. Okay, so first of all, they're not the same, so they're not parallel. And they are reciprocals, 1 over 3 and 3 over 1. Those are reciprocals, but they are not opposite reciprocals because they both have a negative. So our answer to this one would be neither. Being reciprocals is not enough. They have to be opposite reciprocals to make them perpendicular. So number 8, our answer is neither. Okay, here are the problems for 9 and 10. Go ahead and try those on your own right now. I'm going to give you about 1 minute to do them. So copy down the last point that you need, right there, and then work on 9 and 10. Okay, let's look over number 9. So we can see on the left we have 2 over negative 4. So that slope is a negative 1/2. On the right we have 5 over negative 10, which also reduces to negative 1/2. Since these two lines have the exact same slope, they are parallel. For number 10, on the left, we have 6 over 8, which reduces to 3/4. On the right, we have negative 4/3. Now, if we look right now, we can see that the one on the left is a positive, the one on the right is a negative, so they're opposites. 3 over 4 is a reciprocal of 4 over 3, so they are opposite reciprocals, which make them perpendicular. So number 10, the two lines are perpendicular. That means they will cross at a 90-degree angle. All right, I'm going to go ahead now and give you 11, 12, 13, and 14 all at the same time. Okay, go ahead and copy 11, 12, 13, and 14 down. You're just looking to get that last point written down for each one. Make sure you put them in the right place. And then we're going to pause the video for about 5 minutes so that you have a chance to work on these. And then when we restart the video, we will go over these 4 problems.
Okay, for numbers 11 through 14, we're going to tell whether these two lines are parallel, perpendicular, or neither. So in order to determine that, we have to find the slope of each line. So in the red, I've got negative 4, 1, and negative 4, 12. So I'm going to do y minus y, that's 12 minus 1, and then x minus x, negative 4 minus negative 4. That's going to be 11 divided by 0. So this slope is undefined. Okay, for the second one, I'm going to do 10 minus negative 8 over 6 minus 6, which is 18 divided by 0. That slope is undefined. Since both of those slopes are the exact same, these are parallel lines. Now, just FYI, if I was going to write the equation of these lines, the equation of this line right here is going to be x equals negative 4 because both of the x's are negative 4. And over here on the right, this equation is going to be x equals, they're both 6. That only happens when you have either vertical or horizontal lines, but that's just something that you can take note of and can help you when you go to write equations of the lines. But the answer to number 11 is parallel. Okay, number 12. The slope, we're going to say 8 minus 5 over 0 minus 2. So that's 3 over negative 2. So that's the slope for that one. The next one is negative 7 minus negative 5. Remember, it doesn't matter what order you subtract these in as long as you're consistent. So if I say negative 7 minus negative 5, then I have to do negative 1 minus 2. So that's going to be negative 2 over negative 3, and a negative divided by a negative is positive. So this slope is positive 2/3. Now when I go to compare these, negative 3 halves and positive 2/3, those are opposite reciprocals. Okay, one is positive, one is negative, that makes it opposite. And reciprocal, because 3 halves and 2/3 are reciprocals of each other. So therefore these lines are perpendicular. And so that's the answer to number 12. Number 13, the slope, I'm going to say negative 5 minus 15. And so if I say negative 5 minus 15, I have to say 4 minus 9. And so then I would get negative 20. Watch your signs. 4 minus 9 is negative 5. Negative 20 divided by negative 5 is positive 4. Now just FYI, if we did this in the other direction, if I would have done 15 minus negative 5, then I would have to do 9 minus 4. And so that's going to be positive 20 over positive 5, which would still give me 4 for my slope. Okay, the next one, we're going to say 8 minus 7 over 0 minus negative 2. You've got to watch those signs. So I'm going to have 1 over 2. So my slope is 1/2. So if I go to compare these two slopes, they're not the same. So the lines are not parallel. They're not opposite reciprocals. So what we're going to write for this one is that they are neither, because they're not parallel or perpendicular. They're just two lines intersecting somewhere. Okay, number 14, finding the slope, 7 minus negative 6. Remember that this negative sign, or that minus sign, that's part of the formula for slope. And so if there's a negative, you have to put that in there also. And then I'm going to have 10 minus 10. And so that's going to be 13 divided by 0. That slope is undefined, which means this is a vertical line. So then looking at my next one, I'm going to have 1 minus 1 over negative 4 minus 3. So that's 0 divided by negative 7. That slope is 0, which means it's a horizontal line. So m equals undefined, that's a vertical line. M equals 0 is a horizontal line. And so those are actually our opposite reciprocals. This is a special case. And so for this one, these would be perpendicular. So this is one that you're going to have to remember how this works, that these two slopes are opposite reciprocals of each other.